Hello everyone. So for today's video, I'm going to show you a quick and pretty simple implementation of Conway's Game of Life in Unity. So let's get started. So just set up things first, and then I'll dive into the code. I've used the orthographic projection because it's a 2D game. I set my size to 20, and these are my position and rotations. If you just want to copy them, it'll probably work. This directional light is the default, and I've got my manager. So the tiles are spawned from prefabs. So let me go into that. So this is the prefab. All it is a empty game object with a cube, and the cube has an offset of 0.5, so that the where it starts is the bottom left corner of the cube. So it perfectly fits within one of these grid squares. So we're just using cube for the mesh filter. This is actually one I made in Blender. The only reason I did that was to change the UVs, so I could get this kind of material. But if you just use a black material, it'll work just as well. The only issue is you won't be able to see the grid lines. If you do want to use a similar sort of material, all you have to do is just change the UVs such that they all overlap on top of the UV map, and then just use an image with a white border. So that's the material. Then we've got, okay, so empty parent, prefab, and then manager. And that's pretty much all for the setup, actually. Again, so we've got this parent here, the cube, and the cube has its own script, as well as a box collider, which is important. So let's go into the tile script for each individual tile. So each tile is going to have a material that it uses when it's on, a material that it uses when it's off. It's going to have a public grid manager, just so it can communicate with it. In fact, I don't even know if it needs to. Okay, actually it doesn't even need to communicate with it, so this is actually from old code. Anyway, it's got neighbors and it's got a bool active, so that's going to decide whether it's active or inactive. So to start, we set neighbors to 0, active to false, because we start all of the tiles false, and then we probably don't even need this. So we give it 3 functions. One is set neighbors, which is just how we're going to set neighbors from the grid manager. So just new neighbors is equal to neighbors from the parameter. Right, so in our logic loop, we see if the cell is not active, in which case if it's inactive and it has 3 neighbors, then we turn it active, and we set the mesh render material equal to on. So this will make it appear as if it's white. Otherwise, if the cell is already active, if we have 1 or less neighbors or 4 or more neighbors, we'll set it inactive, and we'll set the material to the off material, which is a black with white border. Finally, we just have an on mouse down, very simple. If it's active, we'll set it off and set active equal to false, so this will turn it off. Otherwise, if it's inactive, we'll set active equal to true and give it the on material, so this will allow you to actually turn it on with your mouse. Now let's go to Grid Manager. So we have our cube prefab here that we're going to instantiate a delay in the game so that it can tell what's going on, and this is going to be useful for interaction. And this public material on, public material off. Actually, I think this is also old code. I don't think we actually use this anywhere. Nope, I don't think so. And we just have a width and a length here. They get initialized at 30, but we can change this in the editor. So this is the main data structure. It's a 2-dimensional kind of array of the tile type. And the tile type is what we just discussed over here. We're going to call it grid. So in start, we instantiate grid to a new tile array with width and length that are defined over here. we start the delay at half a second, and we just go through this kind of two-dimensional loop, going from I to I less than width, and j to j less than length. And we just instantiate these Q prefabs at I and j concerning that identity. Again, it's a cube, it doesn't really matter. And we just have this game object new cube. The reason why I have game object new cube is because I just set the new cube name to I.toString and J.toString. This will just name every cube after its coordinate. This can be useful sometimes, but it's just kind of a quality of life thing. It's not actually going to, we're never actually going to use this functionality very much. It's just so you can see it in the inspector, or the hierarchy actually. So then what we do is just do grid ij equals transform.getChild 0.getComponent tile. So this is where we're actually binding all of the tile scripts to the grid. So after instantiating them at I and j, we go through the entire grid as we're building it, and each of these instantiated objects, oh there we go, so new cube, we're getting the tile script and we're binding it to the grid. So this line is, this is where the magic happens, so very important. This is kind of where we're binding our prefabs and their individual scripts to our data structure. Then we start this coroutine delayed update, and this is the last part of the script. After this, we're done. So while true, we want this to keep happening. Similarly, for int I equals 0, I is less than width, I plus plus, and j equals 0, j is less than length, j plus plus, so we're just iterating through our data structure. Now this is where we actually check for our neighbors. So we initialize neighbors at 0, and we check to the right of, so this happens for every single tile in the grid, every single time the program runs. So we check to the right of it, so I plus 1. If it's active, so there's a neighbor there, we increment neighbors. Then we check to the left of it, I minus 1, j, up, I, j plus 1, so on. This is our cardinal directions, and these are diagonals, because we're going to need to check 8 different spots in all. And each time we find an active neighbor, we just increment neighbors. Finally, we take the block or tile we're looking at, and we set neighbors. So the grid manager knows about all of the other neighbors, while the tile only knows about itself. That's why it kind of needs this helping hand from its neighbors, because it doesn't really have access to that data structure. And then it's able to do its own logic, as you'll see. Now, I actually ran into a big problem here, and I wasted a lot of time because I actually checked my neighbors over here. I did my logic here. And the thing is, you can't do your logic here, because what will happen is if you do it here, you'll check your neighbors while the grid is still in updating. So if you check your tile here before each of the grid tiles have had a chance to look at their current neighbors in the current generation, you might get a mix of old neighbors and new neighbors from the previous generation. So that's why actually when I finish this loop, I will actually loop again, and this time I'll do the logic in the second loop once I've tallied up all my neighbors. Because if I do my logic while I'm still tallying up my neighbors, I'm going to screw up the logic, because again, I'm working with like a partially, I'm updating it and I'm counting it at the same time. So I might be counting stuff from an old generation, or counting stuff from the new generation before the old generation has had a chance to completely finish tallying up. Hope that's not too confusing, but if you make this mistake, then you'll get a chance to understand it. Here I actually do a try catch block here, just because a lot of times when you're checking for neighbors, all of the tiles at the edge of your grid are going to throw a bunch of index out of range exceptions. We know those are there, we don't really care about them, and there's really no point in putting logic so it doesn't check for them. So we just catch all of these index out of range exceptions and throw them away. Okay, so again here I do that second loop, and now that I've updated each of the tile with their new neighbors, now I'm going to be able to do my logic. Finally, because this is the I enumerator, I'm going to do a yield return new, wait for seconds delay. and this delay is what I've initialized over here. But as you'll be able to see, we can change that. So let's do that. Now, if I go out here, I've actually set the width and length to 50. So if I do 30, we'll see what it looks like. Okay, so I'm not updating my camera intelligently or anything for this. So that's going to be a bit of extra logic. But as you can see, if I put one down, it'll instantly disappear. So what I can do is I can set this delay to something like 30 seconds. And now that'll give me plenty of time to kind of come up with something. And I've already got a design in mind that I like to use for debugging this, make sure it's working right. This is kind of a known pattern in the game of life community. It's called the something decathlon. But now I can reduce my delay, and when it's finishing doing that 30-second wait, you're gonna notice this start updating. So there's a couple ways to check if you've programmed it right. One of them is this. Again, you can actually find one of these patterns online. So it's very useful for double checking if your behavior is correct. Let's put the delay up again to 20 seconds. You can also make a small glider that looks like this. It's like an L with a guy in the corner, like that. And I'm going to bring this down again. And this is the simplest one, and this one should simply go down and to the right. So let's wait for that to finish. And there it goes. And again, so as you can see, this is kind of an easy one to program, and it's very easy to check. So we can even like lower this delay down to 0.1. The only kind of issue here is that this grid, it's not, it's limited. So you won't be able to keep scrolling. So if you want to track the progress of something that's scrolling across the screen, you can do that on the official website, but that's a bit more advanced than what I've done here. But yeah, that's pretty much it. So if you want to know more about the game, it's a cellular automaton. You can Google it, Conway's Game of Life. There's a ton of cool videos. Veritasium just did a video which kind of got me interested in this, and I think it's really awesome. I mean, it's even Turing complete, so you can program the game inside of the game, which is kind of mind blowing. But so I hope you found this interesting, and feel free to give it a try. It's really cool. All right, thanks. Bye.